Good morning or afternoon. My name is Devon Gutierrez, and today I'll be speaking to you about bioprinting. So here's today's agenda. We'll be talking about what bioprinting is, the three phases of it, how it works, its relation to cells, tissues, and organs, benefits, current challenges within bioprinting, the relation between stem cells and bioprinting, and the hypothetical situation I was presented with for this project. And we'll conclude with everything we went over. So what is bioprinting? It's easy to think of as a scientific 3D printing, like I stated before. It's broken up into three stages that make it a little clearer to understand. So there's pre-bioprinting, and that's where you want to create the actual 3D model to tell the printer what its job is. And some printers actually have this function built into it. You can also prepare the ink within this phase. For cellular bioprinting, you will mix living cells into the bioink. And for acellular, you'll prepare your material without cells. But for both acellular and cellular, you can add cells after printing. For phase two, that's going to be bioprinting itself. The two main methods are extrusion-based and light-based. For extrusion-based, you want to load cell-laden bioink cartridges into the printer. And for light-based, you'll use photosensitive bioink. And for the final phase of the main objective is to stabilize the structure, and that can be done through treatment with ionic solutions or UV light. So let's talk about the bioink itself because it plays a big role in the formulation of the 3D cell structure. There are three primary ways that cells viability, structural integrity, and biocompatibility. The primary purpose of bioink is to support the growth of cells. It must provide a healthy environment for the cells to grow. The structural integrity is dependent on the bioink during and even after the printing. When done right, you'll not only find strength but flexibility within your prints. The final thing is biocompatibility, and that's the ability to cause no adverse reaction when the print interacts with your body. If the print isn't biocompatible, you'll find your body rejecting it, which in turn jeopardizes the print's purpose. So how do cells, tissues, and organs relate to bioprinting? Well, cells are the base of tissues and organs, and when bioprinting, cells can be placed in the bioink, which brings life to the print. As mentioned earlier, the type of cells is dependent upon the use of the print. Tissues relate because they're essentially a collection of cells that work together. 3D bioprinting enables the creation of tissue structures, as well as some examples being cartilage and esophageal tissue. Organs directly relate to bioprinting because they're made up of multiple tissues that work together. 3D bioprinting can create functional organs by tying together tissues. So here's a list of some of the benefits that can come from bioprinting. You can replace and reduce organ donors, prevent cell rejection, replace animals in testing labs, replace volunteers in drug testing labs. I have a stat here. In 2009, there was 154,324 patients who required organ transplants, but only 18% of those people received transplants due to a lack of organs available. So bioprinting could have ensured a 100% transplant rate because they're planting to the person. So the new organ that's printed out is going to match the individual. Also, the chances of finding people with compatible tissues isn't super high. Again, bioprinting can resolve that issue as well. And then a reduction in animal testing and animal abuse is great, as well as humans not having to sacrifice health for when they volunteer to test different drugs. Some current challenges within bioprinting are on the engineering side because it's still a little underdeveloped. This can be seen in functional elements of the prints. It's the greatest challenge they're facing currently, and it could also affect long-term viability in the prints. Another challenge is clear and defined standardized actions for different prints. So without standardization, it can be like a little bit like the wild, wild west, and that's not something you want when people are printing organs that are going to be inside your body. Stem cells relate to bioprinting as they have allowed for unlimited resources for cells, and they provide great benefit to research within bioprinting. Some different types of printing. Here on the right side, you're going to see micro extrusion, inkjet, laser assisted, and scaffold free spheroid base, which is their newest type of printing. And you can see a photo diagram on the right hand side. So the scenario I was given was, can my father benefit off of this? My father requires a new kidney and has been on a wait list for years. I wrote no because bioprinting has not been developed enough to utilize for real life scenarios, but it's very dependent on my father's age. If you give it time and say he's in his mid 40s and he lives to 85, I don't see why in 45 years bioprinting wouldn't be developed enough to where things would be standardized and working properly, and he can have a new kidney printed out. So yes or no, depending on what the situation exactly is. In conclusion, we went over what bioprinting is, 3 phases, how it works, bioink's role in the printing, bioprinting's relation to cells, tissues, and organs, as well as different benefits and challenges, stem cells relation, and if my hypothetical father could benefit from the science. And here are my resources. Thank you for your time.